Hello, we are Team AI, Aging Intelligently, and today we'll be presenting our project, Drawing to Diagnose, a gamified diagnostic tool for Alzheimer's and Parkinson's disease. Parkinson's disease and Alzheimer's disease are two of the most common neurodegenerative disorders that affect older populations, resulting in gradual loss of cognitive function. As the exact causes are unknown, neither of them have a gold standard or a single method of diagnosis, with both including neurological or cognitive exams, lab tests, and PET imaging. For Parkinson's, early diagnosis includes an alpha synuclein test, which, due to the invasive nature of acquiring spinal fluid, can deter those seeking a diagnosis. For Alzheimer's, memory problems are typically one of the first signs of cognitive impairment, which is tested using cognitive tests often administered in clinical settings. Furthermore, patient factors related to missed and delayed diagnosis of Alzheimer's include lower levels of comprehension, as well as older adults having described cognitive tests as stressful and embarrassing, perceiving these as a threat to their self respect. Therefore, there's an immediate need for the development of tests that don't require extensive understanding of English, can be administered at home or at a place of comfort, and are presented in a fun, less intimidating manner than current tests.
To do this, we built a gamified risk prediction tool for Alzheimer's and Parkinson's disease that is low cost, accessible, non invasive, and designed for the elderly population. Our solution uses machine learning methods such as a convolutional neural network trained on the Parkinson's YOLO dataset. This dataset contains hand drawn spiral and wave images made up of both healthy individuals and patients diagnosed with Parkinson's disease. With this data, we are able to provide a Parkinson's risk prediction. We also used a random forest model trained on the Darwin dataset in the UCI machine learning repository that included features such as tremor and pen pressure across different memory, graphic, and copying tasks to provide a risk prediction for Alzheimer's disease. Our Parkinson's diagnosis model achieved an accuracy of 81.25% and an F1 score of 79.38%. The Alzheimer's model performed even better with an accuracy of 88% and an exceptional F1 score of 98.83%, indicating a strong balance between precision and recall. These results demonstrate strong potential for accurately distinguishing between healthy individuals and those affected by either condition using handwriting features alone.
So, to make the test accessible, we combined drawing based cognitive tests for Parkinson's disease and Alzheimer's disease, presenting them in a game like format through a custom graphic user interface. So, the game consists of 8 levels of different challenges and activities, and these all require the player to either draw or write. So, as the player progresses through each level of the game, our models will work behind the scenes, taking in the inputs from the player and processing either the saved images or the motor control data, and then using this to predict the risk of Parkinson's and Alzheimer's. But meanwhile, the player can continue to progress through the game and enjoy the story of the game. So at the end of every level, the game will have a pop up that presents the player's risk assessment as either low, medium, or high risk for the two different diseases. So ultimately, this project demonstrates how combining deep learning with a fun interactive design can offer new pathways for proactive, affordable, and accessible neurodegenerative disease screening. And this will be an important step toward improving patient outcomes and quality of life for the aging populations. Thank you.